step into the blueprint of a brilliance that defined an era. This schematic captures the intellectual odyssey of John von Neumann, the logical architect of the modern age. The layout maps a profound digital transition, bridging the subatomic realm of quantum mechanics with the tangible hardware of stored program computation. By synthesizing the Bohr model with his eponymous computer architecture and the strategic rigors of game theory, von Neumann transformed abstract mathematics into the infrastructure of global power. From the intricate flow of logic gates to the high-stakes calculations of global conflict, this is the visual legacy of a supreme mind that decoded the laws of the 20th century to build our digital future. Observe the meteoric rise of a cognitive titan. This timeline, titled The Speed of Thought, charts John von Neumann's extraordinary intellectual velocity through his formative years. Age 6. Mentally dividing 8-digit numbers and conversing in ancient Greek. Age 8. Mastering the complexities of differential calculus. Age 22. Simultaneously earning a PhD in mathematics and a chemical engineering degree in 1926. Age 30. Appointed as the youngest founding professor at the IAS, alongside Albert Einstein. As the featured quote suggests, while most mathematicians are limited to proving what they can, von Neumann proved whatever he wanted. This slide documents a life that wasn't merely a career, but a masterclass in the limitless power of the human mind. Welcome to the foundational debugging of existence. In the early 20th century, mathematics faced a critical system failure, logical paradoxes triggered by sets too massive to be contained. As the Level 1 architect, John von Neumann intervened by developing NBG set theory. This slide illustrates his elegant solution, a nested hierarchy distinguishing between elements, sets, and proper classes. By defining a set as a class that belongs to another, and designating proper classes as collections too vast to be sets, he effectively quarantined the logic-breaking manipulations of the past. Through this finite axiomatization, von Neumann stabilized the mathematical universe, ensuring that the laws of logic remained unbroken by the weight of the infinite. Witness the resolution of a great scientific divide. In the mid-1920s, quantum physics was split between Heisenberg's discrete matrix mechanics and Schrödinger's continuous wave mechanics. In his 1932 synthesis, John von Neumann proved these were merely different mathematical dialects describing a single, underlying reality. By modeling physical states as vectors within an infinite-dimensional Hilbert space, he constructed a unified framework for the subatomic world. This architecture of atoms introduced the density matrix and von Neumann entropy, providing the rigorous tools necessary to measure the inherent mixedness and uncertainty of quantum states. Von Neumann didn't just study the atom, he provided the definitive logical structure that stitched together the very fabric of modern physics. Enter the realm where intuition dissolves. Level 3. The redefinition of truth. Here, John von Neumann and Garrett Birkhoff exposed a fundamental rift in reality. While classical Boolean logic relies on the distributive law to maintain mathematical balance, the subatomic world refuses to comply. In the strange landscape of quantum logic, modeled by the orthomodular lattice, the act of measurement itself rewrites the rules. Measuring one variable, such as position, physically invalidates the certainty of another, like momentum, proving that the universe is non-commutative. In 1936, they demonstrated that the common-sense laws of human logic physically fail at the quantum scale, forcing a radical departure from classical certainty into a complex, non-distributive reality. Step into the arena of human decision-making. Level 4. The mathematics of human conflict. Here, John von Neumann transitioned from the subatomic to the social, decoding the hidden logic behind the bluffing at a poker table. By introducing the Minimax theorem and his seminal 1944 work with Oscar Morgenstern, he proved that chaotic rivalries, from economic markets to geopolitical conflict, could be mathematically conquered. This framework axiomatized expected utility, providing the strategic tools for everything from price optimization to nuclear deterrence. It was a revolution that stripped away the mystery of competition, revealing that whether in trade or war, there is always a rational path to minimize maximum loss and master the high-stakes game of survival. Behold the machinery of prosperity. Level 5. The dynamics of the expanding economy. In 1937, John von Neumann dismantled the stagnant models of the past, replacing rigid equations with the fluid power of dynamic inequalities. He constructed a groundbreaking general economic equilibrium model that finally accounted for the complexities of joint production. By applying Brouwer's fixed-point theorem, von Neumann mathematically unveiled the turnpike property, a definitive, balanced growth path. Here, diverse goods and capital converge, expanding at a uniform rate that perfectly matches the interest rate. This slide captures the moment macroeconomics shifted from static observation to a precise science, charting a course for optimal expansion in a world of complex variables. From the boardroom to the battlefield, we reach level 6, the geometry of destruction. In 1943, John von Neumann arrived at Los Alamos to solve the deadliest puzzle of the century, the plutonium bomb. His implosion solution utilized a sophisticated lens system of alternating fast and slow explosives to craft a perfectly symmetrical, inward-moving shockwave. This precise compression was the only way to ignite the plutonium core. Beyond the laboratory, von Neumann served on the target committee, applying his lethal mathematical precision to calculate the optimal blast heights over Hiroshima and Nagasaki. Here, his logic moved beyond abstract sets and games, directly shaping the terminal geometry of the Second World War and the terrifying dawn of the nuclear age. Behold the digital genesis, level 7, the blueprint of the artificial brain. In his seminal 1945 report on the EDVAC, John von Neumann unveiled the architecture that would define the modern era. His masterstroke was the stored program concept, which dismantled the primitive barrier between data and instructions by housing both in a single, unified memory space. This elegant schematic, linking input, CPU, and memory, unlocked the potential for self-modifying code and subroutines. By standardizing this logical flow, von Neumann provided the foundational DNA for nearly every digital device you use today. It was the moment the computer evolved from a rigid calculator into a flexible, universal machine, forever changing how humanity processes reality. Witness the moment computation broke its physical chains, the paradigm shift in computation. This slide contrasts the cumbersome ENIAC era, where programming required weeks of manual rewiring, with the revolutionary von Neumann architecture. By treating instructions as data within a unified memory, von Neumann replaced physical patch cables with the speed of software. The legacy of this shift is as much legal as it is technical. Because von Neumann chose to share his 1945 paper freely, he transformed a proprietary invention into a public disclosure. This tactical move neutralized patent claims, placing the DNA of every modern computer into the public domain. It was a masterstroke of open-source brilliance that ensured the digital revolution belonged to everyone. Explore the visionary intersection of mathematics and biology. Level 8, Self-Replication and the Code of Life. Before the double helix was ever unraveled, John von Neumann utilized cellular automata to theorize the logical requirements for artificial life. He conceptualized universal constructors, theoretical machines capable of reading instructions to build physical copies of themselves and passing that data to their offspring. In doing so, he mathematically predicted the digital, code-based essence of biological reproduction. Von Neumann revealed that the spark of life is fundamentally an information processing task. This slide documents his final, profound realization that whether composed of silicon or cells, the survival of a system depends on the flawless transmission of its own internal code. Enter the high-stakes arena of global survival. Level 9, the Cold War strategist. In 1955, John von Neumann ascended to the Atomic Energy Commission and chaired the pivotal ICBM committee, effectively launching the American missile race. Here, the abstract logic of game theory met the terrifying reality of thermonuclear war. By applying his Minimax theorem to geopolitics, von Neumann argued that overwhelming force and compact H-bombs were the only mathematically sound solutions to halt Soviet expansion. He viewed the Cold War as the ultimate zero-sum game, where mutually assured deterrence wasn't just a policy, it was a logical necessity. His supreme mind provided the cold, calculating framework that defined the era of global nuclear standoff. We arrive at this convergence, the synthesis. This map reveals that John von Neumann did not possess 5 disparate geniuses, but one single, supreme logical framework. By abstracting the universe into pure mathematics, he discovered the universal axiom, the hidden thread connecting every level of his work. From the foundational rigors of set theory and the uncertainty of quantum physics to the strategic depths of game theory, computer architecture, and global geopolitics, the core logic remains unchanged. He proved that the exact same mathematical laws govern the movement of atoms, the flow of capital, the architecture of machines, and the survival of nations. This is the legacy of the logical architect, a unified vision of a world decoded. We conclude our journey through the intellectual foundations of the 21st century with the DNA of modernity. This slide illustrates the sprawling branches of John von Neumann's influence. To the left, His 1937 models and game theory provided the rigorous framework for future Nobel laureates in economics. To the right, his computer designs birthed the IBM 701, fathering the entire modern technology ecosystem. As Nobelist Eugene Wigner famously quipped, "There are two kinds of people in the world, Johnny von Neumann and the rest of us." Whether in the algorithms of our markets or the silicon in our pockets, we are all living within the architecture of his mind. He didn't just predict the future, he engineered its logical infrastructure. This final slide, titled The Architect of Reality, serves as a masterful closing to our odyssey through the mind of John von Neumann. We see a portrait of the man whose intellectual reach spanned 9 distinct levels of human achievement. From stabilizing the foundations of mathematics to engineering the atomic bomb and defining modern computer architecture, his work reveals a singular truth: mathematics is the operating system of our world. As Robert Oppenheimer's tribute suggests, von Neumann was a rare polymath, a mathematician, physicist, and engineer who didn't just study reality, he designed its logical infrastructure. Here, we witness the full scale of a legacy that continues to power our digital and geopolitical present.